So now we're going to discuss the reactions that are going on in glycolysis. It's basically a 10-step process, and I'm going to walk you through all of this process, so bear with me for that. There is a glucose molecule over here. You can see there's a 6-ring structure over here, and this glucose is going to convert itself into glucose 6-phosphate at first. So how is it going to do that? There's an enzyme known as hexokinase. It's a highly regulated enzyme, and we're going to discuss its regulation later on. So this enzyme is going to help this glucose to convert itself into glucose 6-phosphate. Alright, you can see that there's a phosphate attached at the 6th position of the glucose. Alright, so now you all must be wondering that where this phosphate has come from. This phosphate has come from ATP, and that's ATP is going to convert itself into ADP, losing a phosphate molecule, and that phosphate molecule will be caught up by this glucose, and by hexokinase enzymes reaction is going to take place, and now this will convert itself into glucose 6-phosphate. Alright, so what about now? The next step will be the conversion of this glucose 6-phosphate into fructose 6-phosphate. So what happens here is that glucose is an aldehyde while the fructose is a ketone. There's attachment of OH group over here, and it's a 5-ring structure of fructose. Only the glucose has been converted into fructose 6-phosphate, and with the help of enzyme phosphoglucoisomerase. This is the enzyme that is going to convert this glucose 6-phosphate into fructose 6-phosphate. And here you can see that there are double-headed arrows. That means it's a reversible reaction. That means that this fructose 6-phosphate can be converted back into glucose 6-phosphate. However, in the first reaction, when the glucose was converted into glucose 6-phosphate, it was an irreversible reaction. It cannot go back to convert itself into glucose from glucose 6-phosphate, but this reaction is reversible. Alright, so moving on to the next step. Now this fructose 6-phosphate is going to be converted into fructose 1,6-bisphosphate. So what happened here? This happened due to the enzyme. First I'll talk about the enzyme, that's phosphofructokinase. And what happened here is that there's attachment of one more phosphate molecule over here. You can see that. So where this phosphate come from? Obviously it also came from ATP, which was converted into ADP. And why fructose 1,6-bisphosphate? It should be like fructose 1,6-biphosphate, but why is it bisphosphate? I'll tell you why. Because there's distance between these two phosphate groups. If these two phosphate groups were supposed to attach together, then they're called biphosphate. But these two phosphates are very far away from each other. That's why there's a position difference over there. That's why they're known as fructose 1,6-bisphosphate. So that's why the name is justified over here. So after this reaction, after the conversion of this fructose 1,6-bisphosphate, this fructose 1,6-bisphosphate is going to convert into 2 more molecules, and one of them is dihydroxyacetone phosphate, and the other one is glyceraldehyde 3-phosphate. Alright, so this fructose 1,6-bisphosphate has been converted into these 2 molecules with the help of enzyme aldolase. Aldolase is going to act on both of them, and this is going to convert into dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. So you can see it over here that there is aldehyde group attached in the glycerol position, glycerol, and the 3-phosphate is attached over here, so that's why the name suggests glyceraldehyde 3-phosphate. And in the dihydroxyacetone phosphate, you can see acetone is over here and phosphate group is attached over here. However, this dihydroxyacetone phosphate does not participate in glucose, in this glycolysis breakdown, this glucose reaction, until and unless it is converted into glyceraldehyde 3-phosphate. It's a reversible reaction that is going to occur due to triose phosphate isomerase enzyme. And first, this dihydroxyacetone phosphate is going to convert itself into glyceraldehyde 3-phosphate, and then the further glycolysis is going to take place. Alright, so I hope you've understood by now. So now this glyceraldehyde 3-phosphate is going to convert itself into 1,3-bisphosphoglycerate. It is also a reversible reaction, and there is attachment of phosphate group in the first position, and this is aided by glyceraldehyde 3-phosphate dehydrogenase enzyme. So what basically happens here is that there's addition of phosphate group at the first position, and it is known as bisphosphate. I just told you because the phosphate are away from each other, they're not on the alternate carbons, that's why it's known as bisphosphoglycerate. And here's what happened, that there's an NAD positive and phosphate group, and this phosphate group is added inside this bisphosphoglycerate, 1,3-bisphosphoglycerate, and there's generation of NADH and H positive molecule. So here's making of NADH molecule over here, and you can see that this glyceraldehyde has been converted into 1,3-bisphosphoglycerate. All right. So in the next step, will be again a reversible reaction, and what will happen here is that this 1,3-bisphosphoglycerate is converted into 3-phosphoglycerate. The phosphate molecule that was on position number 1 has been removed from here. So where did it go? Basically what happens here is that by the aid of phosphoglycerate kinase, when this is converted into 3-phosphoglycerate, one phosphate group has been removed, and this one phosphate group will be taken up by the ADP and it will convert itself into ATP. So here there is generation of ATP in this step. So what happens here is that 3-phosphoglycerate is again going to react, and this will form 2-phosphoglycerate. Nothing special is going on over here, only 3-phosphate, the position of the phosphate has been changed from 3 to 2, and this will be aided by the enzyme known as phosphoglycerate mutase. That's just going to change the position of phosphate over here. And in the next step, this 2-phosphoglycerate is going to convert itself into PEP, or known as phosphoenol pyruvate. The short form is much easier, so that's why I've written it over here. And the reaction is catalyzed by enolase enzyme. So what will happen here, there will be enol bond formation over here. That's why it's known as phosphoenol pyruvate, and that's how this 2-phosphoglycerate is going to convert itself into PEP, or phosphoenol pyruvate. Now the phosphoenol pyruvate is going to go towards irreversible reaction. This reaction goes only one way, it doesn't go to two ways, and it's going to convert itself into pyruvate. This was the final molecule that we were looking for in the glycolysis. Alright, and this will be aided by the enzyme known as pyruvate kinase. Again, very highly regulated enzyme, and we will discuss it further. So now the reaction has been completed, but this phosphate group has been removed from phosphoenol pyruvate. Where did this phosphate group go? Again, there was ATP over there, and the ATP took that phosphate molecule and converted itself into ATP, right? So here's generation of ATP from this glycolysis chain. So we discussed earlier that this dihydroxyacetone phosphate is not taking part in glycolysis. However, it's converting itself first into glyceraldehyde 3-phosphate, and then the further reaction is going on. So all the reactions are going to be multiplied by 2 over here. So you can see this glyceraldehyde 3-phosphate has 2 molecules over here. This has 2 molecules, 3-phosphoglycerate had 2 molecules, 2-phosphoglycerate had 2 molecules, and phosphoenol pyruvate was of 2 molecules, and now the pyruvate has 2 molecules. So now we can say that the glucose has been broken down into 2 pyruvate molecules. This is what happens here in the process of glycolysis. So if everything has been multiplied by 2, so there will be production of 2 NAD, and there was involvement of 2 NAD, and there was production of 2 NADH. Similarly, there was involvement of here 2 ADP that were converted into 2 ATP, and similarly 2 ADP are converted into 2 ATP in the last step where pyruvate kinase was involved. So if we talk about in general the summary and the yield of all of this reaction, is what happens here is that 4 ATPs were made, 2 over here in this phosphoglycerate kinase reaction, and 2 over here at pyruvate kinase reaction, and out of them 2 were consumed. If you look at the upper reactions over here, 2 ATPs were consumed. They were converted into ADP first, so we're not going to mention that. So 2 ATP were left, so there's production of 2 ATP in the glycolysis, and 2 NADH are also made inside this process, this whole process known as glycolysis. So what happens here is that a 10-step reaction took place, and it formed 2 ATP molecule and 2 NADH molecule for the production of energy. So that was all about the glycolysis process, and in the next section we're going to discuss about the regulation of this glycolysis, so stick around with us.